Hi everyone, in this video, let us understand how to create Amazon EKS cluster on a shared VPC. In the previous video, we saw how to create a shared VPC in one account and share it with another account. Let's get started. So these are the lab instructions. First, we will create the EKS cluster by running the Terraform scripts. Then we will test access to that cluster. Then we will deploy AWS load balancer controller, which is the ingress controller, and deploy one test application to expose that via application load balancer and test it. So let us go to the main.tf. In this, I've configured three different providers. The first provider is for the local cloud9 environment in which this I'm running the scripts. So this is for the account where I'm running this. But I'll be creating the resources in the dev account 1 and dev account 2. In the earlier video, we saw that we created the EKS shared VPC in account 2. So in this video, we will see how to create the EKS cluster in the dev account 1 using the VPC which is created in dev account 2. Okay. So these are the other resources that we saw earlier. So let's get started. If you look at the provider configuration for the Kubernetes, I've used the profile cross dev account 1. I'll discuss why this is required a bit later. Even for Helm also, I use cross dev account 1. We will see that. First, we will go to the EKS cluster module. Here, I've created one more high-level module for creating the EKS cluster, and this module is hosted in this path. So this is where I'm importing that EKS cluster, and I'm using that as a reference here. So if you see the provider, I'm using cross dev account 1. So this is account number 1 in which I'm creating the cluster. So the region name, the cluster name, and the cluster version, and the VPC ID and the public side CP subnet, which is control plane subnets and the data plane subnets. So we will see why we have created separate subnets for the control plane and the data plane. So apart from this, I'm also creating a OIDC connector in dev account 2. This is unlike where we create the OIDC provider in the same EKS cluster account where in the original account. But in this case, we're creating this OIDC provider in a separate account. So this particular resource is to create OIDC provider. Note that we're creating this in account 2, in which we have created shared VPC. This is unlike where we normally create the OIDC provider in the same account where we create the EKS cluster. In this case, we are creating the shared VPC. Let us understand why later. Then I'm creating an IRSA object, which is the IAM role for service account. I'm creating this role in the account 2. We'll also discuss why so. We are creating the second account. Then I'm creating a load balancer security group, and for the ingress rules and the egress rules. So I've commented the remaining code. We'll enable this code and uncomment it later. But for now, let us first create the cluster. Later on, we will think of how to enable the remaining aspect of the code, that is creating the AWS load balancer controller and also deploying the test application. So if you look at the EF vars folder file, you will see that the VPC ID that we created earlier is hard-coded here. Similarly, the control plane subnets and the data plane subnets. As we discussed earlier, the control plane subnets are used for connecting the control plane and the data plane. These subnets are very small, half size /28, which is 16 IPs times 3 subnets, which is 48 IPs. It is always a good idea to have a dedicated subnets only for the control plane. Similarly, the data plane subnets will be of size /18, which is 16,000 IPs times 3 availability zones, which is 48,000 IPs, which are for the nodes and the parts. So in this case, When we create a EKS cluster, we're also creating a managed node group. And for creating the managed node group, we have to provide the subnets for data plane. So this is where we're passing the data plane subnets. And public subnets also we have configured here. So there is another variable for creating a service account for the load balancer control that we will discuss later. So let's first proceed further and run the Terraform commands in this folder. Terraform init. Then let's run Terraform plan. This will take a while. It has to configure the plan. So as you see, the EKS cluster module is configuring some add-ons also that we will discuss in detail. So this is the plan. We are adding 59 resources and 0 chain, 0 destroy. This is a brand new plan. So this is a security group ID and the load balancer controller IaaC role and the command to access the cluster. So let's proceed further to run the Terraform apply with auto approve. So if you see, it is printing the plan and proceeding further with the creation of the resources. So it is creating the EKS cluster, which may take around 10 minutes or so. It is creating the required IAM roles, the policies, the KMS keys required for EKS. So this is where the cluster is getting created. Now let us proceed to the AWS console and see this in action. So if I go to my primary account, this is where I'll be deploying the EKS cluster. Let's go to the EKS console. So if you see, the cluster with name EKS Shared VPC is getting created now with the latest 1.29 release. We will come back to the screen once the cluster is created. We'll spend some time in exploring the various options and the configuration. I'll pause the video for now until the cluster is created. Okay. So the Terraform completed installing the scripts. So this is the output. The application load balance security group ID is this. Open ID connector ARN is this. So this is the one which is created inside the account number 1, which is where the EKS cluster is created. And we have created one more in the second account. So this is the OIDC, which is created in the second account where the VPC is created. So this is the AWS load balancer controller IaaC role. Please note that this is created in the second account, not the first account, because this is where we will be creating the resources such as network load balancer or application load balancer. Let us first copy the output. So let's first understand the cluster configuration. Let's go to the console. Your primary cluster, primary account. This is where the EKS cluster is created. So if you see the networking section, the VPC which is being used by this cluster is the one which we have created in the second cluster, and this is being shared. So the owner of this is the second cluster. And these are the control plane subnets. If I just click on one of the subnet, you will see that this is a smaller subnet that we have reserved only for the control plane. It's last 28, and few IPs are taken by the control plane nodes. So apart from the networking, we will also look into the compute section. One node group is created with the name platform. It's a managed node group, and these are the instance types. The subnets that we use for the node groups is the data plane subnet, which are the bulky subnets, which are /18. So if you look at the size of the subnets, it will be /18, which is 16,000 IPs. So these are the subnet range. So far we have created an EKS cluster, and this is the OIDC provider. So let us go to IAM service in this account, and you see that the OIDC provider is created in this account also. By default, when you create the EKS cluster, the OIDC provider is identity provider is created in the same account. But for our testing purpose, for our lab purpose, we have created a one more OIDC in the second account. So let us go there and check. Let me go to the second account. So here, if you see, if you go to EKS, ensure that there is no cluster created in this. So there are no EKS clusters here as expected. Let's go to the IAM. So if you go to identity providers, we see that one OIDC is provided in this account as well. So this is what we will be using for our ARSU. That is IAM role for service account. We'll come back to this a bit later, but for now, let us first test access to our cluster. So to test access to the cluster, we need to run this command. So one thing we need to note is here when you run this command, we have not provided any profile, but we created the EKS cluster with a different profile. So if you see the main.tf, and if you see the module EKS cluster, we are using the profile called cross dev account 1. But if you don't use that, and if you simply use this command alone, it will not work, because whatever the IAM identity that is attached to this particular cloud9 machine is what will be used to authenticate with the cluster. But we are not using the identity of this cloud9 machine. Instead, we are using the identity of this cross-dev account 1 profile to create the cluster. So we have to use this profile to access our cluster. So what we will do is, let us first copy this command and copy this also, the profile name. This is the AWS profile. So what we will do is we will add a hyphen profile parameter and run this command to create the field context of the cluster. Okay. Now a key context is created for this account number one in which we created the EKS cluster, and that key context is configured in our root home directory, in our home directory rather, in the .root folder config file. So if I simply run kubectl get nodes, I should be able to see the nodes in this cluster. There are two nodes, and if I see the pod in this cluster, we will see only the system parts are there right now. We have not created any application parts. So one more thing I wanted to show before we proceed further. In the EKS cluster, when you create, we also have added some add-ons. So there are different add-ons. AWS distro for OpenTelemetry, VPC CNA, which is a networking engine, proxy, and the core DNS, and CSA driver. These are the EKS managed add-ons. We will discuss this more in a separate video. These are already configured as a part of the EKS cluster module that we have used it. Okay. Now, next, we created the cluster. Now we will go and deploy the AWS LB controller. So let us uncomment the code. First, there is a file here, EKS-addition.ts1. So let us rename this, remove this one here. Now I am using EKS Blueprints add-on module. So we are using EKS Blueprints Terraform add-on module. So if you go to the GitHub, so this is the Terraform AWS EKS Blueprints module. So we are leveraging this module to deploy. In fact, we are not leveraging this exactly. We are leveraging the add-ons module. Okay. So the add-ons module will deploy various open source and the EKS add-ons. So in this case, we wanted to deploy the AWS load balancer controller, and I'm just enabling that using one local variable. And this is the configuration. The service account name I can provide, and there is a helm values file which I am passing through this configuration. So within that, I am passing the VPC ID and the role ARN. So the way it works is, when you deploy this AWS load balancer controller, we have to configure the service account with the role for the IaaC to work. So the role I've already created earlier. If you look at one more module I'm using, load balancer controller IaaC. So I'm creating this in the first, in the second account rather. And if you see, this is the name of the role, and I'm attaching the pre-built policies. I don't have to create the policies. These IAM policies are already available in this module. I just need to enable this flag. And the OIDC connector, which is going to trust, for this role is the one which we created in the second account. This is not the one in the primary account, the secondary account where the VPC is created. So this is the new resource we have created. OpenID connector, new in this account group. And the name of the service account is this in the system namespace, and this is the name of the service account. This name is passed via variable here, which is the AWS load balancer controller is the name of the account. So this is how we are configuring the load balancer controller. If you look at the Helm values, if I go to Helm values configuration, I mentioned the VPC ID, and this VPC ID is coming from the previous lab where we created the shared VPC, and I said create service account is false because manually I wanted to create the service account and annotate it with the IAM role. So that's the reason I am saying create is false, and I also need to enable certain flags. Enable backend service group is equal to false. This is important because we are creating the load balancer controller. We are creating load balancers in one account, whereas our EKS clustering the nodes are a different account. So if you don't enable this, what happens is the load balancer controller will search for the EC2 node in that account to add certain security group rules. But we don't have any EC2 nodes in the account number 2 because there is no EKS cluster. EKS cluster in the first account. So load balancer controller will not be able to deploy the ingress objects properly. So this is important to know when you deploy either MLB or ALB to disable the backend security groups updation. So normally when you attach the pods to the load balancer, it will try to update the security groups. So we are disabling that. Instead, we will only manually do that. When we deploy the application, we will look into that. So for now, important to note that we are not creating the service account as a part of the Helm configuration. Instead, we are creating a service account ourselves um, here. So let us enable that configuration. So if you see, we are creating a service account with annotation to the IAM role. This IAM role is coming from the IRSA module, and this is created in the Cube system. So let's go ahead and create this add-on. Let's go to our directory and do Terraform plan. So the plan is okay. Now there is a plan to add 6 resources, 0 to change, 0 to destroy. So let's proceed further and apply the plan to deploy the AWS load balancer controller in the cluster. Let's give it a few minutes. I'll pause for now. From completed applying the resources. So let us check the AWS load balancer controller. Let's go to the Cube system namespace. The pod. So we see that 2 parts are there, and let us look at the detailed view of this pod. So this pod will be using a service account, and the name of the service account, let's find out. This is a service account which is configured for this pod. Now let us describe the service account. So as you see, we created a service account in the Terraform, and the annotation contains the role ARN, which is the role that we have created in the secondary account. This is important because the AWS load balancer controller pod will assume the role in this account and create the required NEB or AEB resources in the second account. So the reason for this is we wanted to isolate the networking components in one account from the compute, which is EKS cluster pods. Because if you have restrictions with respect to security compliance configuration for the load balancers, you can directly manage that in the secondary account. You don't need to come back to the primary account where the workloads are running. That way, you can have the separation of duties between the application owners and the networking team. That is the primary reason. So, this is what it is. Now, let us look at the role in the secondary account, and let's go to the IAM service. So if I go to the roles, you can see that the AWS LB controller role is created. These are the pre-built IAM permission policies attached to this role. The trust relationship contains the OIDC, which is in the secondary account, which is very important because the role is in the secondary account, and my OIDC also should be in the same account. This is different from the account where the EKS cluster is created. Okay. Now let us proceed further and create a sample application. And for that, let's go back to the code and uncomment some of the application code. So in this example, we are just deploying a sample application, and this application is available in a separate directory, and I'm providing the name as the namespace for the namespace name as shared VPC test one. Even the app name is also the same thing, and we are deploying this um, resources in the cluster, and we will also configure an ingress object for this particular Kubernetes service. So the ingress object will be using the annotations, which is internet facing. It's a public facing load balancer, and the target type is IP. This is important because we don't want to register the node ports into the target groups, because node ports will add extra latency. So if you use an IP from the load balancer directly, the parts will be connected and reached. So security groups is important because we have disabled the backend security group updation flags in the load balancer controller installation. So we have to provide a manually created security group. So we have already created that earlier in the Terraform automation. This is a security group ID, and looking at the subnets. We also need to provide the subnet IDs where load balancer will be created. If you look at the TF file, the subnet IDs also we have provided. So this is a simple Kubernetes cluster IP service where we're running a simple hello world application at port number 8, and this is created in this namespace, which is getting created through this particular template file. I'm not going in detail with the template. It's just a simple Kubernetes service deployment and typical object files. So let's this time I'll directly do Terraform apply. I'll not do any Terraform plan just to save time. Let's give it some time. So the Terraform apply completed. Now let us see the new namespace which is created for the sample application. So shared VPC test one is created. So if I go into this namespace and see all the resources, let's see what all the resources created. So we have one pod running and one cluster IP service running and one deployment. Then let us also look for the ingress object in this namespace. So there is one application load balancer created with this name. So let us go and check. This has to be created in the secondary account where the VPC is created. So let's go to the secondary account, go to the EC2 console, look for load balancers. So we see one load balancer is created. This is internet facing, and this is a VPC which is shared, and the listener port is this. There are two rules. So the default rule is to send the traffic to this target group. So you see that the target type is IP, which is always recommended option. Then we have one target, which is the pod. So if you go to the console and see the pod IP, so let us run the command again. Get pod hyphen wide. So the pod IP is 10.137.197. So if I search for that, you will find it. So please note the port in which the container is exposed or running is 8090 within the pod container. But the port at which the load balancer is exposed is port 80. So if you see the load balancer listener, it's at 80 port, right? So, but within the target group, you have registered 8090 port directly. So if you see the node port service normally, you will see the list of instances in the cluster registered at node port. Since it's a IP type, we see the port IP directly. So that means the application is deployed successfully. And before we test it, let's first check one more thing. Look at the security group created for this. So if you go to security, look at the security group. This is the one which we created, managed by Terraform. Normally, the AWS load balancer controller creates this based upon the ports, but application ports, but we created it because we have cluster in one account and load balancer in different account. So we have to do this. And if you go to the ingress rules, so we added allow all traffic from all ports, all protocols from all sources. Similarly, one outbound also we created it. So this outbound is from the load balancer to the pod, and this inbound is from public internet to the load balancer. Okay. So let us just click on the DNS name and let's see if this works. Okay. So we see one output requesting the pod, from so and so part. Hello from the shared VPC. So that means the application is working. Okay. So let us summarize what we have done so far. We created the EKS cluster in account 1. Okay, this is our primary account. And the reason for this is the application teams will be managing this compute resources, and all the security control policies will be applied to this account. And the networking team can own and manage and configure the load balancers, VPCs, routing, security policies, etc. in this account. So it's a separation of duties for security and control. And since the load balancer is created in this, so we have to create the IAM role in this account and also the OIDC provided in this account. Okay. So with that, we conclude the lab on Shared VPC and Amazon EKS. So just to recap, this is the architecture that we have built. Two accounts, EKS cluster in the first account, VPC load balancer in the second account, and shared them between these two accounts using the resource access manager.